And so one thing I want to point out is we have this white dashed line. That is the cap in the atmosphere. So when the red line, the temperature line, when it's to the left of the white line, air parcels are free to move up in the atmosphere and rise and build up thunderstorms with that upward motion. However, when that red line moves to the right of the white dashed line, that's where the cap occurs. Air parcels are no longer able to move up in the atmosphere. They are capped. They get blocked at that level of the atmosphere. And it's kind of what that purple EL means, is that's the equilibrium layer. That's the layer at which we see air parcels rising to and then stopping. And so where we see that equilibrium level taking place, there at the 550 millibar level, about 12 or 14,000 feet up in the atmosphere, that means air parcels can rise to that level and then they can't rise any further. And so that really inhibits the storms from developing those tall cumulonimbus clouds that we need for storm development. They can't rise high in the atmosphere. So that's why we believe that with this particular system, we're not going to see the severe weather. We do have some storm relative helicities nearing 200, which would indicate the possibility of severe weather, but it is that cap that's going to really limit the development of the storms, as opposed to what we will see Saturday afternoon. See that red temperature line staying to the left of the white dash line all the way up to about the 300 millibar level. That's about where the jet stream resides, about 9 kilometers up. And so this is going to give us more of lift in the atmosphere. It's going to allow those strong updrafts to develop with this particular system. We see much higher CAPE values in excess of 1,000. We see storm relative helicities over 300. We also see that Energy Helicity Index approaching 2. And when we see that happening, again, that is another indicator of the possibility of strong tornadic supercell development.